Okay, I'm going to give you guys a Ferris wheel example here today. On the sheet that you've been handed out, there's one question like this, and there's another one that's a little different scenario. You can try and go ahead and solve it if you like. If you're not quite sure how to go about it, then you can wait until tomorrow, and I'll go through an example similar to it, so you have an idea how to do ones that aren't Ferris wheel questions, but also real-life examples, pendulum-type examples. Okay. You should probably be able to solve it, but if not, don't worry about it, we'll go through it tomorrow. Okay. If you're not quite done just copying this, just get the teacher to pause the video and start it up when you're ready. I'm just going to go ahead and do the example. Okay, a Ferris wheel is loaded at its lowest point, which is 8 feet off the ground. The wheel has a radius of 30 feet. Determine the equation of a passenger's height versus time and produce the graph. Okay? Assume that t equals 0 is when passengers first get on the ride. Okay? And what I don't have there, okay, is the time for one cycle. Is 90 seconds. All right. So, first let's produce the graph. So at t equals 0 seconds, here you are, you're going to be loading onto it, and you're at 8 feet. Okay, so we know it's at 8 feet is the bottom. Okay. Next, okay, we have a radius of 30 feet, so that means the whole height of the wheel is 60 feet. Okay. So if we're 60 feet off the ground at the top of the wheel, or 60 feet at the top of the wheel, plus the 8 feet that we're already off the ground, that puts us up at 68 for our maximum. Okay. And halfway between 68 and 8 is 38. Okay, so the sinusoidal axis is going to be here at 38. Okay, so I would just draw that right away. Okay, so there's the sinusoidal axis. The next thing I know is that it's going to take a full 90 seconds for one complete cycle. So here's 90 seconds. I'm going to break it up into its halves here. So here's 45. Okay. And if you were to break it right up in half again, you would get 22.5 seconds and 67.5 seconds. And these are all times. And the same as you break up the sine wave graphs or the cosine wave graphs up into quarters, you break these ones up the same way. Okay. So you know that it's going to start out here at the bottom, okay, and it will finish at the bottom. Halfway through the ride, which is at 45 seconds, okay, if you start out at the bottom, halfway through the ride you're going to be at the very top. Okay. So here we are, right at the very top, okay. And then at 22.5 seconds, okay, you'll be at the middle of the wheel, and 67.5 seconds, you'll be again at the middle of the wheel. Okay, so here's our wave, goes up like that. Now for a complete sine wave, okay, we're going to need another quarter here. Okay, so I would have to add another 22.5. So that's going to give me 112.5. And if you continue the wave on, another quarter brings you back up. So now I have a complete sine wave. You can do this as either sine or cos. I'm choosing to do it as sine. So now I break it up the same as when I go to make up my actual equations before. There's one full sine wave right there. So then we create our sine equation. Okay, this is going to be t instead of theta, the blank, and a blank on the end. Okay. And again, everything here should be fairly simple to figure out. It's all the same as it has been all the way along. The only thing that's a little bit different is the period's a lot different, or the horizontal stretch is a lot different than what we're used to. Okay. The sinusoidal axis here is at a positive 38, so we go plus 38. Okay. How far to the right has the start of our wave gone? Okay. Well, it's 22.5 to the right. Okay. So we go minus 22.5. Now I'm going to skip past the horizontal stretch and go to the amplitude. If you look, okay, the amplitude from 38 to 68 is 30. Okay, just the radius of the wheel. Now the only thing we have to figure out, okay, is the new period. Okay. So to get that number, okay, the number that goes right here, it's equal to 360 degrees divided by the amount of time for one cycle. So in this case, 90 seconds for one cycle. Okay. So one complete cycle took us 90 seconds, just like we said in the question. Okay. So divided by 90 is equal to a 4. Okay. So we put a 4 in there. And then just rewrite the equation. Y equals 30 sine 4 to t minus 22.5 plus 38. Okay. So there it is, the final equation. Okay. If we were going to do this as a cosine wave, okay, a little different, there's a couple of ways we could do it. I'd want to extend it if I want like a regular cosine wave out in another 22.5. So we'd be looking at 135. And that will put us back up here. Okay, and as I said before, okay, everything stays the same in the cosine here. The 30 is the same. This is cos instead. The 4 remains the same. T, and on the end it's still plus 38. The only difference is how far have I shifted to the right. Okay, the cosine wave here doesn't start here. Okay, it starts at a peak. Okay, so it starts right here, which is at 45. So it's t minus 45. Okay, so if you wanted to express this as a cosine wave, this would be the cosine. Okay, and if you wanted to, you could also do a negative cosine wave, which actually starts right here. Okay. If you want to take a minute and figure out what that actual cosine wave is, you can. I'll just write it here. Okay. And I'm going to look at this right here. This would give me one full cosine, okay, except it's negative. So it would be a negative 30 cos 4. This hasn't gone anywhere. If I start here and end here, it starts right at 0, so it would just be t. My amplitude, or my sinusoidal axis, is still 38. So any one of those three equations can describe the same wave. Okay? Most of the time, I probably won't be asking you for 3. If you can give me the sine or the cos, that will be fine. Okay? So you should be able to do at least the Ferris wheel question on the handout, and probably the other one, but if you can't get it, don't worry about it. We'll do one on Wednesday.